Hey, welcome back to Algebra 2. Today's lesson is 3.1 on exponents. So this should be nothing new to you. We've been doing exponents for years now, but we're going to talk about the difference between the rules and the definitions. So exercise 1 is just reviewing those laws. So x to the a times x to the b is x to the a plus b. So for an example here, we have b squared, which is the same thing as b times b to the fifth, which is b times b times b times b times b. So how many b's do we have altogether? B to the seventh. So with that first law, that's why we keep the base and we add the exponents. Please remember you need to have the same base. So if you have x squared times y cubed, you can't do anything with that because we don't have the same base. So it's just going to stay x squared y cubed. So in B, when we're dividing exponents, it's sort of the same thing. So we subtract exponents when we have the same base. So if we go back to our definition over here, we have y to the 6. So we have 6y's in our numerator. We have 9y's in our denominator. And once you cancel them out, because anything over itself is equal to 1, we're left with 1 over y cubed, which is the same thing as y to the negative 3. C, whenever you have a power raised to a power, we multiply them. An example here is when you have something like k to the third power raised to the third power, it's basically your definition says anytime you have something raised to the third power, you have it 3 times. So now we go back and use our law up at the top in A, and then we have the same base, so we add the exponents 3, 6, 9. But most people find it easier to remember that when they're right next to each other like this, you just multiply them. With D, some of the problems with D is sometimes we forget that when we have something raised to the second power, that you have to multiply everything inside. So again, if we go back to our definition, it's like multiplying it 2 times when you have something squared. So that's going to be the 25. Remember, there's really a 1 hiding here. So that's where this x squared comes from, y to the y to the 8th power. All right, so another way that you can look at it is with our law, just make sure that you kind of distribute that to each of the exponents inside the parentheses. So there were 1's here. So 5 to the first power now becomes 5 to the second power. X to the first comes x squared, and y to the fourth is y to the 8th. Kind of revisiting what we saw up in B, when we have x to a negative exponent, what that basically does is if it's in the numerator, reminding yourself this is really x to the negative a over 1, it basically pulls itself into the denominator. All right, so in this case, if we have x to the negative a, that x to the a power falls into the denominator and we make it positive. Similarly, if you have x to the negative a in the denominator, it's going to pull itself up into the numerator, remember this is over 1, and make it positive. So here are a couple examples. S to the negative 3 is 1 over s cubed, and 1 over p to the negative 2 is p squared. So F is a law that we're going to be using quite a lot during the rest of this unit, and that's going to be our exponent, our rational exponent law. So when you have x raised to the m over n, I'm just going to remind you here that this top number here, this is the power, and the denominator is the root. So when you take a look at this, you're going to have x, the nth root of x to the m power, or another way you could write this is the nth root of x to the nth power. Either way is acceptable. So here's an example. We have y to the 3/4. So that means 3 is the power, and that's why that's here. 4 is the root, and that's why that's there. The only time that we don't write a root in there is if it's square root, because we kind of assume if you're going to do, let's say you do y to the 3/2, we're going to take the square root of y to the third power. Would it be wrong to put a 2 in here? No, but just understand that if there's no number there, we are always assuming it's a 2, it's a square root. So exercise 2. Let's look at some examples here. Again, my advice to you is listen to what I'm telling you, put the pencil down, and then pause it and write it down. Okay? So take a look here. Numerator, x to the third times x to the fourth, keep the base, add the exponents. In the denominator, I have x to the fifth raised to the second. We're going to multiply them. X to the 10th. It's telling us here to leave no negative exponents in our answer. So we can't do 7 minus 10 because that would be x to the negative 3. It's telling us specifically, do not leave negative exponents. So this is going to be the same thing as x, no, it's going to be the same thing as 1 over x to the third power. All right, so how I look at that is I say 10 minus 7, kind of do it backwards. Normally we do 7 minus 10 to get x to negative 3. If you're doing 10 minus 7, that just means it's falling into the denominator. In B, we have a 1 here. So this is x to the 8th, y to the 4th, over x to the 5th, y to the 7th. Now we can use our rules of exponents. I'm starting at the top and saying 8 minus 5. So that means that my x is going to stay in the numerator. And we have 8 minus 5 is 3. On the y's, because the bigger y is on the bottom, the y is going to stay in the denominator. And 7 minus 4 is 3. Now in C, what I think I would do first is let's simplify the x's and the y's. So first let's take the x's and then we're going to look at the y's. And I just did that so I can't see what I'm doing. All right, so keeping that in mind now. We have x to the negative 2 minus a negative 6, which is x to the fourth power. And then we have 4 minus 1, which is y to the third power. In D, we're going to have to do some simplifying first. So here, let's do multiply. Let's remember to distribute these two. So you get x to the negative 6, y to the negative 8th over, again, distribute these two, x to the negative 4, y to the negative 12. That's a bad 4. And now simplify. Negative 6 minus a negative 4 is x to the negative 2. Right, a double negative is a positive, so it's negative 6 plus 4. And negative 8 minus a negative 12 would be y to the positive 4. But again, we're not using negative exponents, which means we're going to leave the y to the fourth up in the numerator and drop the x squared into the denominator and make it positive. All right, exercise 3 says simplify each of the following expressions, write each without the use of negative exponents. So same law applies here. Don't flip out because of the fractions. We're going to basically do the same thing. We're going to do x to the 1/3 times x to the 1/2. Don't flip out. You have a calculator. So in your calculator, you're going to do 1/3 plus 1/2, which is x to the 5/6, divided by x to the 1/6. And now you're simply going to put in your calculator 5/6 minus 1/6, and you get x to the 2/3. It's easy to do it when someone else is doing it for you. All right, so x to the 1/2 times 5 is x to the 5/2 over 3/2 plus 3 is 9/2. Again, we're not going to write this as 3 and 3/2. That just gets kind of nasty. So we're going to keep them as fractions because now I can put in my calculator 5 over 2 minus 9 over 2, which is 5 minus 9 is 4 over 2. So it's x to the negative 2. So it's telling us to use without using negative exponents. So this is going to be 1 over x squared. Now don't forget that 4, that multiplying that 4 to the third power. So this is the same thing as 4 to the third power times x squared over 32x to the 8th. 4 to the third power is 64. 64x squared over 32x to the 8th means that we're going to keep the 2 in the numerator and the x to the 6 is going to fall into the denominator. Because 8 minus 2, starting at the bottom, 8 minus 2 is 6. Or you get 2x to the negative 6 if you wanted to do one extra step. 2x to the negative 6, and then that's the same thing as our 2 over x to the 6th. All right, moving on to exercise 4. Rewrite each expression below in both simplest form and using radical expressions. So it doesn't want us using rational exponents. It wants us translating these into radicals. So basically all we're doing in A is just using our formula we talked about. And I'm going to remind you, when you have x to the a over b, a is the power, b is the root. So what this means is this is the third root of x to the 5th power. You could also write it like this, but usually the first way is more acceptable or easier to work with. All right, so using our rules here, 5/2 minus 3/4. Let's put that in our calculator, and we get x to the 7 over 6. Just rewrite this as the 6th root of x to the 7th power. This is the same thing as x to the positive 3 over 2, which is the square root of x to the 3rd power. In D, we have x cubed. I'm going to rewrite this for now as x to the 1/2 so I can subtract them, because 3 minus 2 is 5/2. So x to the 5/2. So rewrite this as the square root of x to the 5th. Now beware with this thing. You get 8 to the 2/3 times x to the 10/3, in which case now we're going to have this you can put into your calculator if it confuses you. All right? But basically what you can do is say, what's the cube root of 8? It's 2, and 2 squared is 4. So you get 4x to the 10/3, but it's going to be 4 cube root of x to the 10th power. And f. So let's do the same thing. We're going to kind of distribute that 1/3 to each one of these, and we get 27 to the 1/3 times x to the 1/3 over, and I'm just going to rewrite this as 6x to the 1/2 just to make it a little simpler when we subtract. So the cube root of 27 is 3, right? Because 3 times 3 is 9, times 3 is 27. Again, we can use your calculator. You get 3, and you do 1/3 minus 1/2, which is 1/6, which is negative 1/6. All right, x to the negative 1/6, which is the same thing as 3 in my numerator and the 6th root of x in the denominator. Okay, so taking a second look at that, I kind of forgot something here. So I had 3, I forgot that I had a 6 in my denominator. See this 6 that I had here? I should have brought that down to here. So my final answer should be 1 over 2 6th root of x. Sorry about that. All right, so exercise 5. Which of the following is equivalent to the cube root of 8x to the 7th power? So they're just telling you to rewrite it in with rational expressions. So this is the cube root of 8 times the cube root of x to the 7th. So the cube root of 8 is 2, because 2 times 2 is 4, times 2 is 8, times the cube root is 7, but we can rewrite this as x to the 7/3. So here, right here is right there, number 2. Very similar question than we see in exercise 6. It says the expression of 1 over 4x squared. So I'm thinking this is probably going to be a negative exponent, so these are not my answers. So this is going to be the square root of 4x to the negative 1. We're going to rewrite this as the 4x to the 1/2 times negative 1. We can rewrite this as 4x to the negative 1/2, which we can take the square root of 4. Oh, because it's negative though, it has to be 1/2, and then x to the negative 1/2. Is that one of our answers? I hope so. Yes, it is right here. All right. So notice the confusing part about that is this negative, when I apply that to this 4, becomes that 1/2 right here. Because the square root of 4 is 2, but the negative drops it into the denominator. Okay, so that is the end of 3.1. If you've been assigned to do the independent practice, then make sure you get that done. If not, you can work on it in class tomorrow. And until then, as always, make good choices.